So let's take mapping notation and replacement notation to the next level. This is what this podcast is all about. Watch this. This is cool. It says write the equation of the image after each transformation. Well, this becomes really, really cool. Watch. This one says we're going to be shifted 2 units to the right. Okay, so going to the right and left, that's the H value. Going to the right is a positive 2. 3 units down, that's the K value. Going down, -3. So if you look at this original equation, y equals to f of x, you know and I know this has to change because this is y minus k equals to f of x minus h. And let's just put the values in there right now and see what happens. So there's the k value, there's the h value. Chuck them in. Y minus, substitute the -3, f x, substitute the +2, clean it up. So you're going to get something that looks like this. Y, there's the minus, watch out for that. So this is y +3 equals to f of x, no change in sign, -2. Done. Now you're probably saying to yourself, what good is this? Well, what's really cool is when we look at the replacement notation. Look at this. We said then that the x is replaced by x minus 2. The y is replaced by y plus 3. Aha! Replace means replace. Replace means substitute. Look at this original equation here. The original equation was y equals to 3x plus 2. And what's really cool here is now take the y and replace it. So this becomes y plus 3 equals to 3. There's the x. Replace it with x minus 2 plus 2. Okay? Now, watch what happens. Y plus 3 stays as y plus 3. This now distribute 3x minus 6 plus 2. Clean it all up. You got y plus 3 equals to 3x minus 4, combining these two numbers. Subtract 3, y equals to 3x minus 7. This is the new equation of this one, shifted 2 units right, 3 units down. Now you're probably saying, well, that doesn't sound right. Something's wrong with that. Well, you know what I'm going to do? I'm going to do something really, really cool for you right now. I'm going to say, let's just pick a point. Pick a point. Let's pick a point for this. Okay? X, I'm going to let it equal to a point, xy. I'm going to let x equal to 1. So if we put 1 in here, 3 times 1 is 3 plus 2 is 5. So y's got to be 5. That's the point on this graph. Now, according to this, I'm going 2 to the right. So according to this, I am mapping this point 1, 5. I'm mapping it 2 to the right, so 1 plus 2. And I'm mapping it, the 5, I'm going 3 units down. 5 minus 3. So my new point, 1 plus 2 is 3. 5 minus 3 is got to give me 2. That's my new point. Let's prove that this point, 3, 2, actually works in the new equation. This is going to freak you out. So x is 3. Minus 7, 3 times 3 is 9. Minus 7, look at that. Lo and behold, y equals to 2, which is exactly the point that we mapped. We mapped this to 3, 2. Isn't that wild? So now you can take any equation in the world, throw a mapping at it, throw a replacement at it, throw a transformation at it, and get a brand new equation which works. Oh, this is just awesome. Okay, so with that in mind, let's now go on to something a little bit more complicated than just plain old linears. Let's go to a radical function. Now, this one again, watch what I do. This says it shifted 1 unit left, so that means my h value is a -1. 5 units up, which means my k value has to be +5. Look at the function. The original function was y equals to f of x. You know that we can make this y minus k equals to f x minus h. Plug the values in. You've got the values right here. Just plug them in, right? So this becomes y minus, substitute in a 5, f of x minus, substitute in a minus 1. Okay, clean it up. Y minus 5, f of x plus 1. Look at the mapping. The mapping says, or I should say the replacement. The replacement says x becomes x plus 1. Y becomes y minus 5. Guess what? It's a replacement. Let's replace. So if you throw this in there, watch what happens then. This becomes y minus 5 equals 4 minus x plus 1. And don't forget that this has to be squared. Oh my goodness, this is going to be ugly, isn't it? Not really, because you know and I know that x plus 1 squared means x plus 1 times x plus 1. Foil it, you got your x squared plus x, so this is 2x plus 1. So check this out. This becomes y minus 5 stays the same, equals to the square root of 4 minus x squared plus 2x plus 1. Distribute the negative. Boom, 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 right? This becomes, now I'm running out of room. Clean it up a little bit. Okay, this now becomes y minus 5 equals to 4 minus x squared minus 2x minus 1. This becomes y minus 5. Just clean it up. All we're doing is just some simple little algebra. Minus x squared minus 2x combined plus 3. There you go. There's the new equation. And you can actually put this on your calculator and you'll see that it switches things around. So look at this last question that I have here before I end this podcast. Look at this last one. It says just plain old mapping notation. So what you have to remember in mapping notation and replacement notation means two different things. So always tell me, what is the H, what is the K? In this particular case, the H then means I'm going to the right 3. So that means I'm a positive 3. This one means I'm going down 5. That is a negative 5. And always, always, always go back to the equation y minus k equals to f of x minus h. And all you have to do is substitute those guys right in there. This becomes y minus a minus 5, f x minus the 3. And all you have to do after this is just clean it up. This is y minus minus becomes a plus 5, and this is f of x minus 3. If you want to put the replacement out there, fine. X becomes x minus 3, y becomes y plus 5. And if you had some sort of crazy equation out here, all you'd have to do is substitute those in. Isn't that just awesome? Look how far we've gotten. Oh!